so in this video we're going to work through some of these examples of problems where we calculate potential energy and kinetic energy. So the first example that we have here, and this is similar to an example that is in your notes, but it's not exactly the same. So we're going to work this example in the video, and then I will work the examples that are in the notes in class, just so you have both of them. All right, so in this example, we have a boulder. It is sitting atop a hill, and in the hill, we have two positions where the boulder, if it rolls down, it could get stuck at point B. And the distance from the top of the hill to point B is 10 meters. Or the boulder could roll all the way down to the bottom of the hill, which is down here, and it can roll a distance that is A, or to point A would be a distance A, which that distance is a 20-meter fall. So it's like the difference between the boulder falling 10 meters versus falling 20 meters straight. Now the boulder has a mass of 8 kilograms. So let's look at what we would do with this. So we want to find, if this is our boulder, and it's on top of this hill, I'm just going to kind of redraw that picture. We have a height right here that is 10 meters, and then we have another height right here that is also 10 meters, so that the total height from the top of the hill to the bottom of the hill is 20 meters. And we also know that the mass of our boulder is 8 kilograms. So what is the potential energy, or in this case, we're going to use the gravitational potential energy of the boulder when it falls, when it rolls down the hill from the top of the hill to point B. All right, so I'm going to call this potential energy B, so that distance it falls. We know the equation for gravitational potential energy is mgh, where m is the mass, g is the gravitational acceleration of 9.8 meters per second squared, and then h is the height. In this case, it's the height to point B, or the distance from the top to point B, which in this case is 10 meters. And we know the mass of the boulder is 8 kilograms. So since I know these things, I can plug all of these into my equation. So gravitational potential energy is mgh, so that's going to be 8 kilograms times my gravitational acceleration, 9.8 meters per second squared, times my height of 10 meters. So we plug all that in, get our handy dandy calculator. I'm just using the one on my phone. All right, so I'm going to take 8, multiply it by 10, and multiply it by 9.8, and that gives me 784 units would be kilograms times meters per second squared times meters. This unit right here, we combine those two, that becomes a Newton, and then we multiply it by meters. So this whole thing, this whole unit, is going to be represented with a capital J for joules. So 784 joules of gravitational potential energy is experienced by this rock if the ground was at point B, if it stopped at point B. But what happens if it doesn't stop at point B? What happens if it moves the entire distance from the top all the way to the bottom of the hill? Well, in this case, all right, I'm just going to label this B. In the case that it goes from the top of the hill to the bottom of the hill, it hasn't just fallen 10 meters. It's fallen 20 meters. So we need to have our height. This is the height to point A. It's not 10 meters anymore. It's 20 meters. Now, did the mass of the boulder change? Well, no, it didn't. So I'm just going to put mass of the boulder is still 8 kilograms. Did the gravitational acceleration change? Nope, which means g is still going to be 9.8 meters per second squared. So I'm just going to move this up so we got a little bit more room to work. And we're going to now take our equation, gravitational potential energy to point A is going to equal mass times the acceleration due to gravity times the height at point A, and that's going to equal 8 kilograms times 9.8 meters per second squared times 20 meters. And then we're going to plug that into our calculator. So 8 times 9.8 times 20. Do you think that's going to be a bigger number or a smaller number than to point B? I hope you said bigger number because we're multiplying by a bigger number. We're doubling that distance. So we're kind of doubling the potential energy. So this is going to give us 1,568. Remember the units? Kilograms times meters per second squared gives us newtons, times meters gives us joules. So this is almost, or should be exactly twice the amount that we had up there, or at least pretty close to it. All right, so that's how we use the gravitational potential energy equation to help us find the potential energy of an object due to the fact that it's sitting above the surface of, or some surface. All right, next we're going to look at kinetic energy. All right, so our next example is going to be an example of using the kinetic energy equation. So in this first example, we have a bird. The bird has a mass of 2 kilograms, and it's flying. So it's flying with a speed of 5 meters per second. So let's bring that over to our whiteboard here. So we've got a bird. Let me just draw a real quick bird. All right, there's our bird. And it's flying along, flapping its wings. It's going this way with 5 meters per second as its speed. And the bird has a mass of 2 kilograms. Now, we know the equation for kinetic energy is 1/2 mv squared. Now, I want to point out again, this squared is only on the v. So it's only on the velocity. So let's look at what we have and what we don't have. I don't know what the kinetic energy is yet. That's what I'm looking for. Do I know the mass of the bird? Yes, the mass of the bird is 2 kilograms. Do I know the velocity or the speed of the bird? Yes, the speed of the bird is 5 meters per second. So once I have these down, I'm going to just say mass is equal to 2 kilograms. Velocity is equal to 5 meters per second. I'm now able to plug in to my equation. So kinetic energy is equal to 1/2 times my mass, or 2 kilograms, times my speed, 5 meters per second, and the speed is squared. So when we think back to PEMDAS, and we think of our order of operations, it's parentheses and then exponents, right? Well, these parentheses here are my multiplication parentheses. I don't have to do anything with the 2 except know that it's 2 kilograms. So it's not parentheses. These parentheses are not representing an operation or a grouping of numbers. They're just separating my numbers with their units away from other numbers. So I don't have to do anything with parentheses in this, but I do have an exponent, so exponents go next, which means I'm going to square my 5 before I do any of the other calculations. So if I do that, I have 1/2 times 2 kilograms, and then square my 5 meters per second. Well, 5 squared is 25. Meters per second squared is meters squared over seconds squared. Now I'm going to multiply that. Well, if I do this on the calculator, I'd type in 2 times 25 divided by 2. Well, 2 divided by 2 is, 2 times 25 is 50. Then divided by 2 just gives me 25. So mathematically, this is just going to give us 25, but what's the unit? I've got kilograms times meters squared over seconds squared. Now, if we take this unit and separate it out a little bit differently, I've got kilograms times meters per second squared. I know that is a Newton times meters. So I have newtons times meters. Newtons times meters is a joule. So my answer here, my kinetic energy of this bird, is 25 joules. All right, so pretty straightforward. We don't have to remember anything about height or gravitational acceleration. It's just, I know the mass, I know the speed, I do the math. So let's look at another example of this. All right, in this case, we're going to kind of work backwards. All right, so we have a skydiver. The skydiver has a mass of 82 kilograms. They jump out of the plane. If they have a kinetic energy of 110,864 joules, can we find the velocity of this skydiver? All right, so let's write down what we know. gonna move this up. Let's go ahead and clear this. All right. So I've got, here's my airplane. All right. So there's my airplane, and then I have my skydiver jumping out of it, and they're just like, wee, falling up the plane, and they're going this way. All right, they're falling. So I know the skydiver has a mass of 82 kilograms. All right, so mass of 82 kilograms. And I know that right before they hit the ground, or right before they deploy their parachute, that they have a kinetic energy of, 110,864, I don't know, I don't remember. Yeah, 864, wow. 110,864 joules. That's their kinetic energy. I want to know, what is their velocity? Okay, so we're going to do a little bit of algebra first. I'm going to write down my kinetic energy equation, Ke equals 1/2 mv squared. And remember, sometimes if you don't want to write Ke, you can just use K. That stands for kinetic energy as well. And I want to do the math to get velocity squared by itself. That's the first step. So we know if we are doing the order of operations, we have to follow a certain step. But when we do want to get things isolated and rearrange equations, we kind of do that backwards, right? Like we're going to subtract or add things first to get a variable isolated, and then we're going to do our multiplication and division. So in the case here, I'm going to rewrite this to Ke equals m over 2 times v squared. So now I have this factor m over 2 that I want to move away from v squared. So if I have a fraction that I want to move, I'm going to multiply both sides by the reciprocal of that fraction. So I'm going to multiply both sides by 2 divided by m. That means over here my m cancels out and my 2 cancels out. So that's going to give us 2 Ke over m equals v squared. Now, so we didn't have to do any addition or subtraction. We did our multiplication, division, and moved things over. And now we need to do our exponent part, right? I have an exponent on my velocity. I want, at this point, just my v by itself. So I need to do something to get that squared removed. And remember, in algebra, every time we do something to one side, we have to do it to the other side. So to remove the square, the way that we do that, the easy way to do that is we take the square root of my velocity. But if I take the square root of my velocity, that means I also have to take the square root of the other side of the equation. So doing the square root of my velocity, or my velocity squared, is just going to give me v. But that means when I take the square root of that other side, I can't simplify that anymore. So it's going to be 2k over m, or 2ke over m. So my velocity, or my speed, is equal to the square root of 2 times my kinetic energy divided by my mass. So let's see if we can figure out what that's going to be. So I'm going to take 2, and then we're going to multiply it by my kinetic energy, which is 110,864 joules. And then we're going to divide it by our mass, which is 82 kilograms. So putting that in our calculator. All right, I'm just pulling up my calculator. Okay, looks like that. I'm going to first do the stuff underneath the radical. So first I'm going to take 2, multiply it by my kinetic energy, 864, and that gives me a big number, 221,728. And now I'm going to divide that by 82, which gives 2,704. All right, probably can't see that. But now we need to do the square root. So I'm going to press the square root button. And on this calculator, I didn't have to do like my answer, but if you're using one of the TIA 30s or the TIA 84 type things, you'll do your square root button and then your shift or your second and then your answer button. And that way you don't have to remember what that number was or write it down because it's stored in here. So this gives me a speed of 52. And if we break down our units, remember joules is kilograms times meters squared over seconds squared. And then I'm dividing that by kilograms, which means my kilograms are canceling out, leaving me with meters squared over seconds squared. But then I take the square root, which gives me meters per second as my speed. All right. Now, these are two equations that you I know some of y'all we talked about this little triangle to help you rearrange equations when we talked about the force equation, F equals ma. We can create that for both of these. So we've got GPE equals mass times the gravitational acceleration times the height. And then we have KE equals mass over 2 times v squared. All right, so I just took the 1/2 and the mass and squished them together. So these are our two equations. Now we can take this and squish it together into our weight. All right, so we have, remember, weight is mass times gravity, acceleration due to gravity. And here I took the 1/2 m and I just kind of squished it together. So if we wanted to, we could make one of these triangles for both of these. All right, we've got on this one, we're multiplying our weight times our height, and that's going to give us GPE. All right, don't have enough space there. And then on this one here, we are multiplying mass over 2 times v squared to get our kinetic energy. All right, so you can have these equations on your note card or these triangles, or both. All right, I'd recommend both because being able to do the math is important. All right, so that's it for this video. It's a long one, and I'm sorry, but we did get some good examples. All right, so I'll see you in the next video.